हेलो स्टूडेंट्स, वेलकम टू फिजिक्स पाठशाला। आज हम पढ़ेंगे अबाउट थर्मल एक्सपेंशन ऑफ मटेरियल्स। इसका मतलब ये है कि मटेरियल्स विल एक्सपैंड वंस heat is given. If any heat is given, suppose there is a thin rod, if heat is given तो it will expand, इसका लेंथ बढ़ जाएगा। If some plate is there, metal plate, heat is given, it will expand in its dimension or area बढ़ जाएगा। If some spherical or cubic volume is there, so once heat is given, it will increase its volume or there is a cubical expansion. If length is increased, we will say that is linear expansion. If area is increased, we will say superficial or aerial, superficial or area expansion. If there is an increase in volume, we will say volumetric expansion or volume or cubic expansion. In all cases, heat has been given. Suppose here amount of heat Q is given and original length was L. Now temperature of this material has increased from T to it became T dash and length became L dash. That means there is a change in temperature, that is change in temperature is final temperature minus original temperature, and there is a change in length, final length is L plus delta L. If there is a change in length, this indicates this change in length is proportional to change in temperature and proportional to original length. Hence, we say this change in length is equal to L some constant times delta T. This constant alpha we say coefficient of linear expansion. Coefficient of linear expansion. In similar manner, if area is increased, suppose from S now new area became S dash, there is a change in area, that is S dash minus S. This S change in area is proportional to original area and proportional to change in temperature. Implies that this change in area is equal to S some constant beta times delta T. Here beta is coefficient of superficial expansion or area expansion. In similar manner, the change in volume is equal to original volume times gamma and delta T. Here gamma is the constant, we say coefficient of cubic expansion. The relation between alpha, beta and gamma is these coefficients are again temperature dependent. Now suppose temperature is between 0 to 100 degree, we take average value of alpha and average value of beta and average value of gamma. In that case, there is a relationship between alpha, beta and gamma is alpha by 1 is to beta by 2 is equal to gamma by 3. If it is a cube of length L, here the volume is L cube. Small change in volume is dV. We say delta V was V gamma delta T. Small change in volume dV is equal to V gamma dt. Now dV by dt is dV by dt is our V gamma question 1. Again, if we differentiate this V, we find dV by dt is equal to 3L square dL by dt. Question 2. We know L is this is our dV for a small change in length. This LDL becomes L alpha dt. Now we can write here from equation 1 and 2 we get V gamma is equal to 3L square dL by dt. V is L cube gamma is equal to 3L square dL by dt is here L alpha. We can say it is L alpha. Here L cube L square cancelled. Gamma now became 3 alpha. In similar manner, we can prove beta is equal to twice of alpha. Hence, the relation between alpha, beta, gamma is alpha is equal to beta by 2 is equal to gamma by 3. This was a thin rod. This expansion happened because once heat is given, this material is made up of molecules. Materials are made up of molecules. Once heat is given, these molecules of the material started vibrating at higher velocities. Hence, the intermolecular distance between them is increased during the process. Hence, once intermolecular distance are increased, there is a increase in length. In similar manner, if there is a plate, both dimension is increased, hence there is an increase in area. If there is a volume, then there is an increase in volume. There is an increase in volume. Hence, these are the thermal expansions of material. Now we can write this L final length is L plus delta L or L plus L times alpha delta T. Hence, L dash become L times 1 plus alpha delta T. In similar manner, final surface area is old surface area or original surface area times 1 plus beta delta T. And final volume is original volume times 1 plus gamma delta T. Now it is clear. Now it is clear that once temperature is increased, there is an increase in volume. Once there is an increase in volume, density is mass per volume. Hence, change in density is delta rho, that is rho minus final density. Here, once volume will increase, this density will decrease. That means rho dash will be less than rho, hence 1 minus gamma delta T. We got four equations 1, 2, 3, and 4. From this equation of volume, we observed that volume keeps on increasing. Volume keeps on increasing if temperature is increased. If we draw a graph between volume and temperature, we find there is an increase in volume once temperature is increased. Accordingly, there is the density will decrease as temperature will increase. But there is an anomalous for water. To save marine life, suppose there is a lake and if temperature of lakes started decreasing and now it's, suppose it has touched 4 degrees centigrade, then at 4 degrees centigrade, density of water is maximum. Density of water is maximum. Now, if the temperature decreased further and it became 3 degree, then the water which was with 4 degrees centigrade earlier, it will remain at bottom of this lake, whereas at surface it will become 3 degree. Then if further decreased, it becomes 0 degree. At surface it will become 0 degree, and there will be a change of state of water from water to ice. Now, at the top of the lake, it will become ice, and if further it goes to there is further decrease in temperature at the surface, then at the surface of the lake will become ice, whereas at the bottom water will be at 4 degrees centigrade because due to density difference, the higher density molecules, higher density water will be at bottom, and at top there will be low density. Low density will automatically will be at the top. This ice density is less than density of water. Hence, once we draw a graph for water, we find there is some difference with other one, that anomaly. Suppose the volume will be, initial volume will be more, and at 4 degrees centigrade, if it is temperature and this is 4 degrees centigrade, at 4 degrees centigrade, volume of water will be low. Hence, density density of water will be maximum at 4 degree. For this reason, water remains in liquid form at bottom of the lake, whereas at its surface it becomes ice. Hence, there is a relief for marine life, fish and all. They used to move or live easily. Hence, we say is there is an anomaly of in the case of water, that volume became lowest at 4 degrees centigrade and its density is maximum at 4 degrees centigrade. Okay, with this we could cover expansion, thermal expansion of material, and in our next class we will study about specific heat capacity of matter.